properties of trapezoids and kites. So if you found your notes sheet, the inside of it has trapezoids and kites to the right-hand side. We're going to take some notes about trapezoids to begin with. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, and those parallel sides are called bases. So this is a base, and this is a base, and we know that it's a trapezoid because it only has one pair of parallel sides, not two. The other two sides are called legs. And so an isosceles trapezoid, remember isosceles triangle had exactly two congruent sides. An isosceles trapezoid is a trapezoid with exactly two congruent legs. So when you're looking for trapezoids, you'll see only one pair of parallel sides. These marks are really important. Likewise, this is a trapezoid, but it's not just any trapezoid, it's a specialized one with two congruent legs. With the isosceles trapezoid, each pair of base angles, this is one pair of base angles, this is a second pair of base angles. Each pair of base angles is congruent, which we know because we see these arcs. Two arcs mean that these two angles are congruent. A single arc means that these two angles are congruent. And another cool feature about an isosceles trapezoid only is that the diagonals will also be congruent. So if we label this TRAP for trapezoid, then TA's distance has to be the same as the distance between R and P. We also have another feature of trapezoids, and that's something called a midsegment. So midsegment has the prefix mid in it, meaning middle. And so it's a segment that's exactly in the middle of these two parallel lines called the bases. And so in order to be exactly in the middle, it has to connect a midpoint of one of the legs with the midpoint of the other leg. And not only does it connect the midpoint to the midpoint, but this midsegment is parallel to each of the bases. And because it's exactly in the middle, it is 1/2 of the sum of the lengths of the bases. So if this is A, and this length is B, and this length is C, then B is going to be exactly half of the sum of A and C. It's the average of them, A plus C divided by 2. Okay, so in our first example, we have a body of a guitar that's a trapezoidal prism, and the front face of that guitar is an isosceles trapezoid. So we're going to write in here where AB, the distance between A and B, is 3x minus 2. The distance between C and D is 3x plus 9. The distance between A and D is 4x plus 5. And finally, the distance between B and C is 5x minus 6. And we're asked to find the length of x, or the value of x. Well, we know that because it's an isosceles trapezoid, the two legs have to be congruent. A leg has to be congruent to a leg. These are our two parallel sides. They do not even appear to be the same length. So if we start by setting 4x plus 5 equal to the other leg, 5x minus 6, and then we solve this equation, we get that 11 is equal to x. So we found x is 11. Now let's put a note on this. We'll come back to this one in just a moment, but it makes sense to find the perimeter of the front face of the guitar now in centimeters. So if x is 11, 11 times 4 is 44, 44 plus 5 is 49, and this should also be 49. And then 3 times 11 is 33, 33 minus 2 is 31, 33 plus 9 is 42. So if we add 49 to 49, we'll get 98. If we add 42 to that, we'll get 140. And if we add the 31, we'll get 171. The perimeter is the distance around the face of the guitar, so we added 49, 31, 49, and 42 to get the distance around. All right, lastly, we need to find the measure of angle A if the measure of angle C is 72 degrees. And so because these are base angles, 72 degrees equals 72 degrees. A, this is parallel lines cut by a transversal. Consecutive interior angles are supplementary. So we'll take 180 minus 72 to get 108 degrees.